All right, we're going to continue our discussion of if statements with a new set of operators that adds a lot to both the power and complexity of the Boolean expressions. So we saw in the last video some information on relational operators which compare two values, right? So, and they can compare things that aren't Booleans. They can typically compare things like numbers. So you can say like number equals 3. Logical operators work on Boolean values. So they combine true and false values in new ways to add additional expressiveness to our Boolean expressions. So we are used to logical operators in the English language. For example, we might say if, so that's the condition, I study hard, so that's one Boolean expression that's either true or false, I study hard, and I practice coding, that's another Boolean expression, I practice coding is either true or false, then I will pass the test. The and combines those two. It is saying that both those things have to happen to pass the test. Now again, kind of like relational operators where I said we're used to it being a little more fuzzy, these are very exact. So when I say if I study hard and I practice coding, then I'll pass the test, that usually means if I kind of do some of that stuff, then I'll pass the test. In programming languages, that and means both have to be strictly true. Both have to be, evaluate to true values, and the combination of those two true things is true. There are three main logical operators we'll be looking at: and, or, we're used to or as well. If I, if I have a big salary or I save my money, I will have money left over, something like that. One of those two things has to be true for the expression to be true. And not basically reverses the meaning of it, right? It flips it from true to false and false to true. So we can use these logical operators to encode more complicated logic in our if statement. So here I say if age is greater than or equal to 21 and cash is equal to 10, then do something. And following the sort of English meaning of this, both these have to be true for this Boolean expression to be true. Now again, we have an intuitive understanding of this and or and stuff like that, but there's actually a very precise definition of these operations. So, and actually I forgot to say, in Java, the and is turned into special characters, ampersand, ampersand, right? Or is two vertical bars. Not is an exclamation point in front of a Boolean value. These are kind of, again, leftovers. Some languages do let us use and or and not directly. Some let us use both. And some have used these special characters for some time, and so it's a little bit historical. And you just need to kind of make sure you have straight which is which. So down here, again, how do you evaluate this statement? Well, first you do the relational operators, because this is a number, this is a number, this is a number, this is a number. We have to somehow combine true and false values with the and. So we're going to turn the relational operation into a true value or false value. This is going to turn into a true or false value. And then we combine those two values to get a overall true or false value. And is an operator, and it works on Boolean values for the left operand and the right operand. And it combines them in the following way. If both of those were false, then it produces a false out of the overall expression. If one of them is true, it still produces false as output. If both are true, then the entire expression is true. So, and only is true if the left operand and right operand are true, otherwise it produces false. So that's just one, just keep that, you have to remember that at some point. Or evaluates it true if anything is true. So for example, if the two operands are false, it produces false. Here there's a true here, here's a true here, and of course there's a true in both places here, and those all produce true. And that's really what it means, again in English, right? That if I do this or this, then one of those has to be true for the overall thing to be true. But it's a little easy to get yourself, confused, and it's best if you somehow force yourself to think of okay, this is an operation, kind of like a plus sign. It operates on the left side and the right side to produce a result of some expression, and the thing it produces is true or false. Not just flips it. So not false produces true, not true produces false, right? It negates it. Now let's build an example over here. Let's see, let's get another int value equals 2. And let's get rid of this thing. Let's get rid of this thing. And so if I say if number equals 3 and value equals 2, print it is true. I'm just going to show that it's true. Else, I'm just going to print if it's false. By it, I mean the value of the boolean expression in the if statement. And get rid of this. We'll leave that done there just to kind of keep track of what's going on there a little bit. All right, so how do you read this again? Well, first, there's an order of operations here. First, you do the relational operations. So let's let me draw, I guess. If number equals 3 is, let me change this thing to, let's make it all true first of all here, so we can make some progress. Okay, let's make it actually work. So we're going to evaluate. What am I not doing here? Draw. All right. We evaluate this expression and this expression. So is number equal to 3? Is 3 equal to 3? This thing turns into true. Is value equal to 2? Is 2 equal to 2? This whole thing becomes true. So when you evaluate this statement, you're basically saying it's true, and looking at that table or intuition, that is true. So that Boolean expression is true. Since it's true, we should be printing out the true statement here. Otherwise, I have to go back and figure out what I'm doing wrong. What am I doing many things wrong? How come I can't erase that? Hello. Clear screen. That's weird. I have lost. All right. Let's run this. It is true. Okay. All right. So this whole thing is true. Let's make both those 3 and run it. It's false because this was true, but this was false. True and false produces false, so it skips over the true part and does the false part instead. Now, I'm going to try something else here. Let's make a new method. Static. I'm going to return a Boolean. So this method is going to produce a true or false value. And I'm just going to call this produce true. In other words, the point of this method is to make a true value. And all I have to do is return true. So that's fine. And down here, I'm going to call produce true. A call has the parentheses, right? This is calling this method. All right, what's going to happen here? Number equals 3 is true. I call this method, which evaluates to something. It returns true. So the call to produce true evaluates to true. True and true is true. And it should print out it is true. Okay, that's great. Let's just make sure something is happening up here. I'm going to add some sort of debugging code, some code, investigative code. I'm going to say here in produce true. Right, so when I call this method, it's going to print out to the console in produce true, return true, and then do whatever happens down there. And again, I sort of hate how the console always needs a little more space. And I didn't even type that correctly. Okay, run it one more time just because the typos bother me. So it called it, it printed that, and then returned true. I'm going to try something here. I'm going to make this false. All right. So what do we expect in this case? Well, let's run it and find out. Hey, it printed out it is false, which is what we expect because that's false. And anything with a false in the and statement skips is not true. It's false. But it did not print out in produce true. In other words, it never called this here. And that's a little subtle. What is happening is something called short-circuiting of logical operators. In other words, if this is false, and there's an and statement here, can this entire thing ever be true? Or do we know it's false? We know it's false because any and expression that has a false as one of the operands is going to evaluate to false. That's based on the table here, right? So if there's a, oops, that's the or. If there's a false, it's false. There's a false, there's a false, there's a false, there's a false, right? So it knows at this point what the answer is. Since it knows this expression is going to evaluate to false, it doesn't even check this side. It short circuits it. And so this kind of thing can produce behavior that is unexpected if this is something that you think is going to, do something important. It may not even do it. Same kind of thing if I use or here, and this part over on the left is true, it doesn't go to this one. Why? Because any or expression that has a true in it is going to evaluate to true. So it doesn't even have to check this one for it to happen. Anyways, if you're expecting some side effect, some action here to happen, it may not happen if Java can decide it doesn't need to bother doing it. So as we build these more complicated things, it's going to run into you're going to run into some issues if you're dependent on it. Anyway, it's a very subtle thing, I think, that most languages do it that way. And you'll have to just, again, be careful when you're trying to do too complicated things in these Boolean expressions. So these conditions are difficult, I think. There's different ways to accomplish the same thing. Here we have if x greater than 5 and y greater than 3, print out it is true. Or you can imagine if x greater than 5, if that's true, check if y is greater than 3, and then print it out. Both these have to be true for this to happen. In this case, both of these have to be true. My light just went out. For it to happen, right? So you'll see different forms that mean the same thing, and you have to really work to try to communicate your intent as carefully as possible. Just like math expressions, where we have multiplication happening before plus, there's an order of operations. The logical operator precedence is not, and then or. So for example, here's a compound. These are all Boolean variables. The meaning of this one is different from the meaning of this one, because here we're going to check the or of these two things first. Are we going to promotion soon or benefits good? And then put that in combination with high salary, and then take the job if that's true. Here we're basically saying if there's a high salary and the promotion soon, these things are combined with the and, or the benefits are good except job, right? So this one implicitly has parentheses around right? Those happen first. So these are combined. Here, these are combined. And it is a real struggle to write these complicated expressions in a way that, one, reflects what you think you're saying, that you don't make mistakes, and two, that other people can understand. And we'll talk quite a bit about how to structure these in a way to make it a little more clear, excuse me, to other people what is going on here. But a lot of errors in code happen in these if statements. They are a huge source of trouble, and they take care and practice to get right. All right, so let's work on these. Thanks.